In this video, we want to show that the following functions are solutions of this equation. This equation here is famous to wave equation. Wave equation is this. Second partial derivative of function is equal to a squared, which a is a constant, is a number, times by second partial derivative of the function with respect to x. Our focus here is not on the wave equation, it's on the mathematics part of the story. We don't want to understand what is a wave equation, where it comes from, and so on. We want to prove that in the first part. We want to prove that this function satisfies this equation, which means that if we take second partial derivative of this function with respect to t, it equals to a to the 2 times second partial derivative of this function with respect to x. Our job is just finding these partial derivatives, and automatically it proves everything. So let's start with finding ut first. First partial derivative of this function with respect to t. When we want to find the first partial derivative with respect to t, this part for us is a constant, is a number. We leave it and we have to focus on this part which has t. Derivative of sine is cosine. But don't forget to multiply by derivative of the inside. Derivative of akt with respect to t is ak. Because it's like 40, derivative of 40 is 4. Ak is a number, so akt with respect to t is ak. This is the first partial derivative with respect to t. Now, we have to find the second partial derivative, utt. For finding the second partial derivative, again we leave sine of kx here. Derivative of cosine akt is negative sine of akt. Don't forget to multiply again by derivative of inside, which would be ak, times by this ak that we have here would be a2k2. So utt, the second partial derivative of u with respect to t, is, I prefer to rewrite it as negative. You will have a negative if you pay attention. a2 k2, we move the constant to the first to write it the first term, then times by sine of kx times by sine of akt. Now let's focus on this. We are going to find the partial derivative of u with respect to x. For finding the derivative of this with respect to x, it's going to be cosine kx. And we are going to multiply by derivative of the inside. Derivative of the inside with respect to x would be k. So derivative of sine of kx is cosine kx times by k. And of course we have to multiply by sine of akt. Now we have to find the derivative of this. The derivative of this answer with respect to x to find uxx. It would be equal to, all of this for u is a constant. Focus on the part that has x. All of this is a coefficient multiplied by that. Derivative of cosine is negative sine kx times by another k because of derivative of inside. So what is derivative of cosine x? It is simply negative sine of kx times k. We have another k as you can see here, so it would be times by k to the 2 times by sine of akt. We can write this answer as negative k2 sine of kx times by sine of akt. At this point, it should be clear for you that why we say that this function is a solution for this equation. Because if you pay attention, utt, the second partial derivative of u with respect to t, is this. If we multiply this by a to the 2, which we have here, because this is uxx, if we multiply this uxx with a to the 2, we have then a to the 2 here also. And it's exactly equal to that. So we prove that the left side and the right side are equal. Let me do it here to finish the solution. So we are going to multiply uxx, which is this, by a to the 2 to finish our solution. Let me name this here 1, and I am going to multiply uxx with a to the 2. A to the 2 times uxx would be negative a2k2 sine of kx sine of akt. By comparing relation 1 and 2, we can see that 1 equals to 2. This means that, because this expression is exactly the same as this expression, this means that utt is equal to a2uxx. So we prove that this function satisfies this equation. Also, for this function, we want to show that this function satisfies same equation. Again, we start with finding ut, the partial derivative of u with respect to t. To find the partial derivative of this function with respect to t, we use quotient rule because it's t in the top, t in the bottom, and we use quotient rule, of course. Derivative of this function with respect to t is 1 times a to t2 minus x to the 2. Minus, we put the t in the top. Derivative of the bottom with respect to t, it would be what is the derivative of this expression with respect to t? It would be 2a2t. Derivative of t2 is 2t. And derivative of negative x2 is just 0. So minus 0. This is quotient rule. If you remember from derivative rules, all over a2 t2 minus x2 to the 2. Let's simplify this expression if it is possible. If we simplify numerator, we can see that it equals to a2 t2 minus x2 minus 2a2 t2. We multiply t in the bracket and we get this all over a2 t2 minus x2 to the 2. This is 1a2 to the t2 minus 2a2 t2 would be negative a2 t2. So this equals to negative a2 t2. Let me write it here. Negative a2 t2 minus x2 all over a2 t2 minus x2 to the power of 2. The bad news is that we have to find the derivative of this again with respect to t. So we have to find the second partial derivative. For finding the derivative of this fraction with respect to t, again we have to use quotient rule. Derivative of the top. What is derivative of numerator? Derivative of numerator would be negative 2a2t times by the bottom a2 t2 minus x2 to the 2 minus the top minus negative a2 t2 minus x2 times this by derivative of denominator. What is derivative of denominator? Derivative of denominator is 2 times bring the exponent to the front times a2 t2 minus x2 to the power of 1 times by derivative of the inside, which would be 2a2t all over the bottom to the 2 again, which would be 4. Now we have to simplify this. Please pay attention what I explained to you here. If you attention, we have a2t2 minus x2 here to the power of 4. We have similar thing to here, and in this big term also we have a2t2 minus x2. We can factor this a2t2 minus x2 from this term and from this term 1a2t2 minus x2 and cancel with the denominator. So please attention again, let me repeat. This term and this term and this term are common between all the terms in numerator and denominator. So The first thing that we can do here is to factor that term and cancel it from the top and the bottom. But attention, we can cancel only one of them, because in the last term here, please attention to this part, we have only this to the power of 1. So we can factor that in the numerator. So if we factor a2t2 minus x2 from numerator, then what we have? From here we have negative 2a2t times a2t2 minus x2. And from this cancels a2t2 minus x2 because we factor and we put it outside. And from second term, what remains is plus, we multiply this negative inside this bracket and it becomes plus a2 t2 plus x2 times by 2 times by this would be 4a2t. This is what we get from numerator, all over a2 t2 minus x2 to the 4. One of these a2 t2 minus x2 with one a2 t2 minus x2 from the denominator cancels, and because I don't want to rewrite all of this again, I am going to erase this from here and make this power 3. So this is what we get for second partial derivative of u with respect to t. Now to simplify this, multiply the brackets in numerator. If you multiply negative 2a to the 2t times by the bracket, it would be negative 2 a4 t to the 3 plus 2a2t x to the 2 plus 4a4, this is a4 t3 plus 4a2t x to the 2 all over a2 t2 minus x2 to the 3. This equals to a2 t2 minus x2 to the 3. Now please pay attention. 4a4t to the 3 minus this and this, if we combine these two terms, it would be 2a4t to the 3. And if we combine this with this, it would be 6a2tx to the 2. This is partial derivative of u with respect to t. The second partial derivative of u with respect to t. Now we have to find the second partial derivative of u with respect to x. What was u? If you remember, u was t over a2 minus x2. So u is t over a2 t2 minus x2. We have to find partial derivative of u with respect to x. We use quotient rule. Derivative of the top with respect to x is 0. 0 times bottom is 0 minus, leave the t, and find derivative of the bottom with respect to x, which is only negative 2x. Because the derivative of this with respect to x would be 0. All over a2 t2 minus x to the 2. Numerator is 2tx over a2 t2 minus x2 to the 2. This first partial derivative. Again, we have to find the derivative of this with respect to x, to find uxx, the second partial derivative. We use quotient rule. Derivative of top with respect to x would be 2t times by a2 t2 minus x2 all to the power of 2. Derivative of the top times by the bottom itself minus 2tx times by derivative of the bottom. Bring the exponent to the front, so you have a 2 times by a2 t2 minus x2 to the 1 times by, We don't need to put 1 here really. And times by derivative of the inside, which is negative 2x. All over a2 t2 minus x2 to the 4. Similar to the previous part, we are going to factor 1a2 t2 minus x2 from numerator, and we are going to cancel it with the denominator. If we factor 1a2 t2 minus x2 from numerator, then from numerator we have 2t times a2 t2 minus x2 from the first term minus, if you multiply these two in here, then you have 4tx, and because you factored this completely cancels and this remains, times by negative 2x. If we multiply negative 2x by this, at the end when we multiply this by this, we have 8tx to the 2 all over a2 t2 minus x2 to the 4. Similar to the previous part, this cancels with 1 power here, so if we erase this from here, finally we have a power 3. Let's simplify the numerator. If we multiply this 2t by this, it's negative 2tx2 plus 8tx2 would be 8tx2. And if we multiply 2t in the first term, it would be equal to, let me multiply this, 2t times by that would be 2a2 t to the 3. Negative 2tx2 plus 8tx2 would be exactly 6tx2 all over a2 t2 minus x2 to the 3. And we are almost done. Now, please attention. Let's compare this equation that we have here, equation 1, with equation 2. We wanted to prove what? We wanted to prove that this function here is a solution for this differential equation, wave equation. Second derivative of u with respect to t is a2 times second derivative with respect to x. So, if we multiply all of this by a to the 2, it should be equal to this. If we multiply all of this by a to the 2, then numerator, in numerator we have, if we multiply this by a to the 2, the numerator would be exactly this expression. Compare this. If we multiply all of this by a to the 2, exactly we get this. And the denominator are the same. So, it is already proved. So this means that a to the 2 uxx would be exactly 2a4 t3 plus 6t, or 6a2 tx to the 2. We multiplied by a to the 2 and we get this all over a2 t2 minus x2 to the 3. So a to a uxx is this, and utt is exactly same expression. Look at this here, utt is exactly same. Is exactly this, 2a4 t3 plus 6a2 tx2 over a2 t2 minus. So by comparing these two equations, we conclude what? We conclude that a2 uxx is equal to utt. So we finished this really complicated, challenging question. I hope you like this video. Please subscribe in my channel and see you in the next videos.